Welcome back, everybody. I think I said at the end of the last video that was the end of the section, but there's actually one extra example that I almost forgot about. So I'll just put this note here because it's useful for the next example, that when you're dealing with a hybrid function, and really, I mean, all of our continuous probability density functions have been hybrid functions so far, but I'm talking about where you've sort of got two different rules for two different sections and then this sort of zero elsewhere. So you've kind of got three or more sections to deal with. This little button, this template, which can be found on your calculator, is quite useful for not only sketching the graph, but also working out probabilities. So let's try one here where we've got this function where we've got like a linear section of graph between 0 and 1, between x is 0 and 1, then another different linear section of graph from 1 to 3 on 2, and then that 0 elsewhere. So first thing we have to do in this example is sketch it. Now, if you haven't used the hybrid function before, you bring up your keyboard, and it's down here in Math 3. And this is the button. Oh, it's no good. I don't want the graph up top. I want my main screen back. Swap. Thank you. This is the button here that brings up the hybrid function template. Now, even though you've got this 0 elsewhere kind of thing, I would actually suggest that you just use the sort of two sections of the template. If you want to, you can push the button again and try to include the 0, but it actually kind of is harder than it should be, and I reckon it's almost just better not to have it. So I'm just going to sort of type in the two non-zero parts of the formula. So there's a half, not the formula, I should say, the function, half times x plus 1. And then after the comma there is where you put the domain. And so that's from 0, 0 less than or equal to x, and x is less than 1. Okay, so you can use the inequality buttons on the same section, Math 3. And then negative 2x plus 3. And the domain for that one was 1 is less than or equal to x, which is less than or equal to 3 on 2. So there's our function, and that's our function sort of, it says undefined, I was about to say that's our function defined on the calculator. But if we're going to sketch the graph of it, like always, if you're in the main screen, you can just highlight that and drag it on. You can do this in the graph and table screen, but I prefer to do this in the main screen. We should see this sort of small section of graph. We'll just zoom in at least once to make it a little bit clearer. And you can kind of tell that the question gave us a grid with some values on the axis, so we suspected that we were dealing with a pretty small, like we'd have to zoom in because it's only going up to 2 on either axis. So if we're going to sketch this, well, you know, we might want to know firstly where is that y-intercept, which we can do with analysis G-solve. So the y-intercept is at y equals 0.5, so I'm going to mark that on first. Then, well, it looks like we've got this point here at 1, 1, but let's just double check that actually is the point there. So I'm going to go analysis G-solve xcal. I'm going to do a y calculation, actually, sorry, when x is 1, just to confirm what's going on at the endpoint of the domain. Yep, and we've got 1, 1. So our first section looks like that. And then, I mean, we can get these values in our heads or by hand, but good just to remind you of how the different ways you can find key features. So analysis G-solve root to bring up the x-intercept, which will eventually come up, yep, as 1.5. So that comes up down here. Now, really key point, because we've obviously just kind of sketched, we've just done the hard part, and probably a good habit to be in to label our key points. But if you just leave your answer like that, you're going to lose a mark. And the reason is because this function also has this third part of the rule, which is just that y equals 0 everywhere else. And it seems dumb, but you have to sketch that part. So you have to sketch like a horizontal line, y equals 0, for the other parts of the graph, which would be everything above x is 1.5 and everything below x is 0. Okay, so we do have to sketch that. I'm going to open circle here because when x is 0, the y value is 0.5, but everything below x is 0, the y value is 0. So you do have to show those parts there. A question like that was on a recent VCAR exam, actually, and there was a comment in the examiner's report about students missing that part, and lots of students lost the mark for it. Okay, and now I've got a couple of other practice questions. So this one says, calculate the median value of x. So remember that just like in the previous example, the median value is, if like all of this area here is equal to 1, the median is the value where it's going to cut this area in half, exactly in half. So if you're going to eyeball it, which obviously isn't the precise way to do it, you know, it'd be something like, if m is the median, it looks like it'd be roughly there, right? But we've obviously got to find it precisely. There's a couple of ways you could approach it. You know, we can actually use some geometry here because we have linear sections of graph, or we could use integrals, and it's really up to you. What's probably worth noting here is that just by inspection, you can kind of see that the area under this first line segment is clearly going to be more than half of the total area. So the value of m, it should be underneath, or m, the position of m, sorry, is going to be between 0 and 1, which means we're really just looking at this function here. Sorry, it's off the screen there. This function here, when we're setting up our integral, and we can kind of say, because of that the median would occur, so from if I integrate from 0 to m, yes, that I'm really integrating under the full function f of x, but really the one that we need to focus on is this one here. So the integral of 1/2 times x plus 1 with respect to x is equal to 0.5. Okay, and we can set that up and solve that for m, which we'll do here. So 0 to m of the function, actually, I'm going to highlight that and drag it down. With respect to x, we want to set that area or that integral equal to 0.5 and solve it for m. I often do this, don't I? How's the standard answer look for that? Is it horrific? It'll probably be horrific, I think. Oh, it doesn't. It's so bad it doesn't. Oh, okay, there we go. Oh, actually, well, you know what? I reckon if this, I would probably have written this as a, to a certain number of decimal places. So, but I didn't. So if we give it as an exact value, we give m equals √3 minus 1. But probably if I'd had my time again, I'd have written correct to 2 decimal places or correct to 3 decimal places or something like that. So if we had done that, let's just see what we would have got. M equals 0.732. Right, so had the question said, had it been worded the way I intended, that's probably the answer we'd be looking for. But if we're sticking with the good habits of giving exact values unless we're told to round, then √3 minus 1 would be the answer. Okay, and then this last question says, find the probability that x is between 0.7 and 1.2. Now this is going to be a little bit tricky because when you look carefully at the graph, well 0.7 is pretty close to where I'd labelled m there. 1.2 is sort of roughly over here. And so we're actually finding an area that is sort of, there's two sections of it, or in other words, with our little hybrid function here, we've got some area under the first linear segment and the other part of the area is under the other linear segment. So there's a couple of ways to approach it, but probably the easiest way is just to sort of find each bit separately, okay? So we can integrate from 0.7 to 1 to find this left-hand part, and then integrate from 1 to 1.2 to find the right-hand part, okay? That's probably the best way to do it, or at least the simplest way, I think, especially when you have the graph to sort of visualize it. So we can say, again, just going to be a bit lazy and use some copy pasting here. So we were integrating from 0.7 to 1 for that sort of the left-hand side of the area. And this is our function. So there's going to be our sort of first part of the area. Then the next part is the integral from 1 to 1.2 of the other linear part of the integral, which was negative 2x plus 3 with respect to x. Okay, so what we could say, I suppose, if we're going to try to summarize that working out, we could say, well, that was equal to the integral from 0.7 to 1 of f of x plus the integral 1 to 1.2 of f of x. Right, and the reason we've separated into those two parts is because we wanted to, they were under sort of different rules, and so what we found was, what did we get? We got 0.2775 plus 0.16, and that'll equal 0.4375. So the graph there kind of giving us a good helping hand at finding a probability where we had to consider areas under two different sections of curves, or linear segments, I should say. So with the CAS, using that sort of hybrid function template that we had, I keep pushing the wrong buttons here, sorry guys. The other approach would have been to use the integral. So we can do this, and it's probably worth seeing as a bit of an alternative to splitting it up the way we did. If we just integrated from 0.7 to 1.2, we'd have to then input the entire sort of function. I'm just going to copy it with respect to x. And that has actually worked as well. So look, that's probably a quicker way of doing it on the calculator, but I think that doing it the splitting up way kind of gives you a better understanding of what's actually happening when we chuck that into the calculator. You know that we've found a piece of area under that line segment and then another piece of area under this line segment. But it is worth sort of saying that, well, there's a bit of a shortcut to do it on the CAS if we use that template for hybrid functions. So I hope that's been helpful. But as always, reach out to your teachers if you need a hand with any of your work from chapter 15, and I'll see you all in the next video. Bye.